Hello everyone, it's me, Professor Aaron Albert, here again with Lesson 35. Let's learn some econ. So, today we're going to go through the Stackelberg competition. It's the last of our oligopoly, and we're going to go through and talk about how Stackelberg and Cournot are a little different. So here's the setup. Cournot, which we've done, firms sets quantities simultaneously. They go 1, 2, 3, shoot. And then they choose their best response quantity based on what they think the other person's going to do. There's no follower, there's no leader, there's no first mover advantage, and we'll note that the output is higher than what happened with a monopoly, i.e. a cartel. Stackelberg has a similar setup, i.e. we have quantity competition, not price competition like with Bertrand. However, one of the firms gets to go first. They get to be the leader. And the other must set their quantity in response. And because of this, things turn out a little different. So, suppose one company can set its quantity first. Reasons we can justify this. Imagine, for instance, that there's fixed plant sizes, and so whoever gets to go first is locked into however big their facility is. Or maybe you have leader-follower for some other reasons. For instance, maybe you have a patent. Maybe you have 5 years of just free access to the market, and then somebody else gets to enter after that period of time. Irregardless, one of the companies gets to go first. We're going to assume a lot of the similar things we assumed with Cournot, and as before, most of these can be relaxed, but we'll just keep these assumptions here to make things easy for our first pass. So let's assume we have linear inverse demand, that is, price is equal to some parameter alpha minus beta times some parameter times q. Let both firms have some marginal cost m. Let firm 1 be arbitrarily chosen as the leader. They go first. Let firm 2 be the follower. They go second. And note that the Stackelberg leader knows that the follower will use best response. Just typical game theory, right? They both know the game. The first person to go knows that the second person is going to follow some function that they can solve for. So therefore, the leader will view the residual demand that the player 2 will use as its demand in the market. So basically, this is going to come down to the equivalence of how before we compared static games to dynamic games. Now we're just doing it with math, not with silly trees and silly boxes. So with Cournot, we solved it like a static game. We found everybody's best response and plugged the best responses into each other, and the intersection of the best responses was the solution. What did we learn from dynamic games? Pretend this was a tree. Reach back into your memories. Let firm 1 go first, firm 2 go second. What do they do? Well, hopefully you remember that we solve these by going to the bottom of the tree. I choose what's best for firm 2. Firm 1 will then choose what's best among what was best for firm 2, and they'll respond accordingly. The only difference, however, is that now we don't have just 2 choices, we have a continuum of choices. We're still going to pass through backwards induction. So step 1, solve for firm 2's best response as a function of Q1, and then 2, Q1 star will end up equaling best response 1 to best response 2 of Q1. This looks similar to what we did with Cournot, but you'll see in practice that doing this sequentially will make a difference in the outcomes. All right, so suppose that firm 2 is observed firm 1. We're looking at the bottom of the tree. What is the profit function for firm 2? See if you can think it out. Hopefully what you came up with was that the profit for firm 2 is just price times quantity for firm 2 minus cost, which should be M, times the quantity for firm 2. You'll note that we can break this down like we did the Cournot game. Namely, what's the price? The price is given above. What's this Q? That's Q1 plus Q2. So we know that firm 2's profit will just be alpha Q2 minus beta Q1 Q2 minus beta Q2 squared minus marginal cost times Q2. How do we find the best response function given this profit function? What do you think we should do? Take a moment, think it through. Hopefully, when you saw the words best response, your first impulse was, man, I should take some derivatives. So let's take some derivatives. You'll note that taking first order conditions of this and setting it equal to 0, you'll find that Q2 equals a minus 2b Q1 minus m divided by 2. Rearranging, we can solve for Q2's best response function. We will find that Q2 as a function of Q1 should just equal a minus m over 2b minus half of Q1. Question now is, knowing this, I'm going to write here, firm 1 knows 2 will do this. Since firm 1 knows firm 2 will do this, what should firm 1 have as their profit function? What do you think? Well, the profit function for firm 1 starts the same as for firm 2, just swap the 2's and 1's. Moreover, we know that firm 2 is going to do this, so we can just plug this in. Plugging that in, we get this. So we start with the same function like what we had for firm 2, just swapping the Q2's and 1's, and we replace Q2 with what we found Q2 will be. Just plug that in. If you plug that in, you can then rearrange and get a relatively simple equation, namely alpha Q1 over 2 minus beta Q1 squared over 2 minus m Q1 over 2. That is firm 1's profit as a function of only firm 1's variables, because they know what firm 2 will do in response to them. Given this profit, what should firm 1 do? Well, firm 1 just needs to maximize their own profit. They can do that by taking the firm 1, i.e. Q1 derivative of their own profit function. By doing that, we find that firm 1's profit is just 0 equals a over 2 minus b Q1 minus m2 when we take the derivative. This rearranges to Q1 equals a minus m over 2b. Backing up a second, how do we find firm 2's profit? How do we find firm 2's output? How do we find both of their profits? How do we find the price? Right at this point, I will tell you, we have everything we need. Firm 1 will do this. This is a number, right, that just has parameters in it. We can plug this into firm 2's equation. You'll see firm 2's equation is just a function of parameters and Q1. We now know Q1 is just a function of parameters, so that means we should have a number for Q2. In fact, if you solve it out, you'll find that Q2 equals a over 4b minus m over 4b. Okay. How do we find price? What are we going to do for price? Well, you'll remember we saw that price equals a minus b big Q. Just plug in Q1 and Q2. When I did it, hopefully I did it right, I found that the price should be equal to a minus 3b times a minus m divided by 4b. Again, this is just some number. We just left the parameters in to make it a little tricky. So, if we look at the solution to two identical setups, namely we start with the same price function, firms with the same cost, you'll see that Stackelberg, Q1 output is a minus m over 2b, Q2 output is a minus m over 4b. Is there a first mover advantage? Yes. Based on our setup, Q1 is twice as much as Q2, and since the price for both firms is the same and the cost is the same, that means Q2 is going to make less money than Q1. Q1 has a first mover advantage. Let's talk about Cornell. Well, with Cornell, they both make the same. No one has any advantage. Moreover, you'll note that if you add these two together, the Stackelberg output is going to be higher. And the price is going to be lower. So, how does this influence, I guess, our opinion of duopolies? In Stackelberg, the first mover has incentive to overproduce, right? If we look at the functions for Q2, Q2 outputs less and less as firm 1 makes more and more. This encourages firm 1 to make more stuff than would be independently good for Q1. Therefore, when we get down to the final solutions, the final output in the market for Stackelberg is higher because Q1 strategically overproduced. In Cournot, there's no incentive for any of this. So, interestingly, first mover advantage benefits the first firm, disbenefits the second firm, and in net encourages firm 1 to overproduce, therefore there's more stuff in the market, so lower price for consumers. Stackelberg versus Cornell, same setup. All that matters is if we're treating this as a static game or a dynamic game. Last thing we're going to do, parting shot, we're going to set up about the same exact problem. Only difference here is let the marginal costs be different for the two firms. Other than that, this is exactly the same as we did in the last slides. Try it out. Let me know how you do. Thanks so much, and see you next time. Bye.